This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. The next concurrency we want to talk about is the circumcenter. So the circumcenter is the point of intersection of the perpendicular bisectors of a triangle. So you recall from your constructions that the perpendicular bisector of a line is a line, say AB, is the line which perfectly splits that line AB in half. So this line here would be our perpendicular bisector. And we call it a perpendicular bisector because it's a line which is perpendicular to the line AB. So the steps to find the circumcenter of a triangle: first off, we have to find the equation of our perpendicular bisector. So you'll recall, to find an equation of a line, you need two things. You need to find a point on the line, and you need the slope of the line. So the point that we take is the midpoint of the line, because we know that the perpendicular bisector of AB up here, say, splits AB perfectly in two, so that point there is the midpoint of AB. So to find a point on the perpendicular bisector, we can just use that midpoint since it lies on the line of the perpendicular bisector. And then what we need to find is the slope of this line, and we'll do that by finding the opposite slope or the perpendicular slope to each of our lines along our triangle. Now we're going to have to do this twice, because in order to find the point of intersection, we're going to have the equations of two lines, and their point of intersection, which we'll solve with simultaneous equations, will give us our circumcenter. So now let's just take a look at an example about how we go about doing this. So we have an example here where we're asked to find the circumcenter of the triangle with vertices 4, 6, -4, -2, and 10, 0. So the first step of our solution is to take two of these vertices. So I'm going to take the first and the second vertex first off. So here and here. My first step is to find their midpoint using the midpoint formula, filling in our x1, our y1, our x2, and our y2 into the midpoint formula. We get a midpoint at the point 0, 2. Next, we find the slope in between these 2 points. So using our slope formula, y2 minus y1 all over x2 minus x1, giving us a slope of 1. But that's the slope of the line in between these two vertices. What we want is the slope of the perpendicular bisector. So if we want the slope of a line perpendicular, and say the slope of this line here is equal to R1, then the slope of this line up here needs to be so that, let's say we call this M1 and M2. We need to have M1 times M2 to be equal to -1, -1. So in order for that to happen, our perpendicular slope for our perpendicular bisector is going to be -1, because then we'll have 1 times -1 1 times -1, which is -1, which is what we want. So now that we have the 2 bits of information that we need, our point on a line and the slope of the line, we can use our equation to find the equation of the line y minus y1 equals m times x minus x1. So our y1 in this case is 2, our m is minus 1, and our x1 is 0. So filling those values in, we get the equation of our perpendicular bisector to be x plus y equals 2. That's the equation of one perpendicular bisector. Next, we take two different points. So I'm going to take minus 4, minus 2, and 10, 0. And we're going to repeat the same steps again. So for the second part, we find our midpoint between these 2 points here. Our midpoint between these two. And we find, using our formula, that our midpoint is 3 minus 1. We get the slope in between these 2 points. And when we fill in our slope formula with our various values for x1, y1, x2, and y2, we get a slope of 1 over 7. And if we have a slope of 1 over 7, and we want to get to the perpendicular slope, we need to flip our fraction and change the sign. So flipping this fraction here, our 1/7, gives us 7, but then we need to change our sign. So our slope for our perpendicular line, our perpendicular bisector, is going to be minus 7. And again, we fill those values into our equation for the line. So we have y minus y1, but since y1 is minus 1 already, minus by minus gives us a plus 1. Our minus 7 is our slope, and times x minus x1. x1 is 3. We expand this bracket on the right hand side and simplify to get the equation of our second perpendicular bisector to be 7x plus y equals 20. So now our third and final step is going to be to take the two equations that we found, our first equation, x plus y equals 2, our second equation, 7x plus y equals 20, and we're going to use our simultaneous equations to solve these equations for x and y. So if we just change the sign across on our first equation, so multiply this equation here by minus 1, then we'll have minus x minus y equals minus 2, and then our minus y will cancel with our plus y if we add these equations. A minus x plus a 7x leaves us with a 6x, and minus 2 plus 20 gives us 18. Then we can just divide by 6. Cancelling on the left leaves us with x equal to 3. Then we can take this value and we can plug it into one of our equations. So one of our equations was x plus y equals 2. We already know x is 3, so that means 3 plus y equals 2. And then all we have to do is subtract 3 from both sides. Minus 3 plus 3 cancels, leaving y is minus 1. So that leaves us with our circumcenter having coordinates x equal to 3 and y equal to minus 1.